if I were to now say that hey, instead of this loop, if I want to find a continuous surface like this, how can I do that? Now that we know this, all that is changing here is I can take this entire surface charge. For example, in this question, we are looking at a charge Q that is distributed uniformly as a surface charge density that is uniformly distributed. That means if I have a surface like this charge is like distributed uniformly. What we are seeing now is you have a loop wire. You know what is the electric field. Now, how can I apply that to this problem? You notice that, hey, I can break this guy into small little loops. I can make a small little loops. Previously my radius was fixed, but here my radius is going to change. So previously what you had as the radius which was fixed is going to change as in this case, we're going to call it rho, and the rho changes from 0 to A. From here, it's going to change. From the previous question, R is going to change as rho. Because previously my R was fixed, but now I'm going to take section by section, a loop by loop, yeah, a loop by loop. If I create a loop by loop that is expanding, then I completely encompass the whole surface. Then I'm finding P at this location 0, 0, H, whereas in the previous question, I was finding it at 0, 0, Z. Z hat, right? So the Z is becoming H now. From the previous question, the Z is becoming H, fixed as H, yeah? Z is H. So if I have a small little dq, in this case, this dq is going to be the charge on this guy. So my previous q that I had, the total q that was fully on this circle, the total charge I had fully on that circle, that total charge is now going to be the small little dq, which is rho s 2 pi rho d rho. How is it rho s d pi rho d rho? The reason being why dq is rho s 2 pi rho d rho is, if I have a loop at a distance rho, I know the length of this loop is going to be 2 pi rho. Length is 2 pi rho. Circumference. Then this small little strip, right? The width of that strip, the width of the strip is going to be d rho. If I go ahead and cut the strip, if I go ahead and cut the strip and make it into a rectangle, if I more cut the strip and make it into a rectangle, all that I got is a long ribbon like this. The length of this ribbon is going to be d rho. I mean, the height of this ribbon is going to be d rho, and the length of it is going to be 2 pi rho. Isn't it? I go cut that round strip into a ribbon, expand it, that becomes 2 pi rho. So I need to find this area, which is 2 pi rho d rho. So that becomes 2 pi rho d rho here, times the charge density, surface charge density. This is Coulomb per meter square, and this is a meter square. So when I multiply, I get my dq. So from my previous problem, I need to replace the r by this. That means my dq is this. From the previous problem, I had this as my z. I had this as my q from the previous problem. So q needs to be replaced by dq. It has been replaced by dq. My z has been replaced by h, has been replaced by h. So I had r square. My r is replaced by rho. R has been replaced by rho. Little electric field due to this small little charge that is surrounded around here. So when I go ahead and substitute the values of dq, right, from the previous, my total electric field now is going to be integrated from all these strips up. For example, a strip like this, a strip like this, and a strip like this, up until rho from 0 to A. Rho is from 0 to A. I need to do that integration. Fortunately for you, that integration has been given. The integration has been given, and that integration, if you notice, is going to reduce to the electric field in two scenarios. When H is greater than 0, it is of one form, less than 0, it's one form, and greater than 0, it is of another form. Notice that when it is less than 0, the direction of the electric field, there's a z hat missing here, and there's a z hat missing here. So the direction of the electric field is in the negative z hat direction. So electric field is in the negative z hat direction. When I am in the positive H, so this is H greater than 0, this is H less than 0, right? This is negative Z. When I am in the positive H, the Z is positive here. At a region lower than the plate, the direction of electric field is pointing down. At the region greater than above, a region above the plate, the electric field is pointing up. Very obvious, right? If this guy has a plus charge, if I get a unit positive charge in the top, that unit of positive charge is going to be shot up, right? The plus charge is going to shoot up this way. If I bring in a plus charge below the plate, it's going to go down, isn't it? So that's why it has a negative Z. That's why it has a negative Z hat. This is useful when you go into an infinite plate. When you go to an infinite sheet, all that you need to do is change the A to the limit A tends to infinity. When the limit A tends to infinity, you get the electric field to be a very small little expression, rho s over 2 epsilon naught. How do you get that was what we are looking at.